All right, get ready, because today we're taking a deep dive into surviving on Mars.
Yeah.
Imagine, touching down on that red planet, feeling that lighter gravity, looking up and seeing, a pink sky.
Yeah.
But hold on, before you even think about packing your bags, we need to go over some serious stuff.
Yeah, Mars has a certain, romantic appeal with its rusty red plains, the towering volcanoes, but let's be real.
Yeah.
It's incredibly harsh.
It's a totally different world compared to Earth.
Right.
Like it's alien.
Totally alien, yeah. For starters, the atmosphere, incredibly thin. It's over 100 times thinner than Earth's, and it's mostly carbon dioxide, so say goodbye to breathing without a spacesuit.
Yeah.
And that thin air, it means incredibly low air pressure.
Right.
You know how water boils at a lower temperature when you're up high in the mountains?
Yeah.
Well, on Mars, the boiling point is so low that liquid water would just instantly evaporate.
I never thought about that.
Yeah.
I knew about the need for spacesuits, but I didn't realize the air pressure would have such a
It's a big deal.
dramatic effect. Yeah, it's starting to sink in how challenging it would be.
Right. And we haven't even talked about the temperatures yet.
Yeah.
I mean, the average temperature on Mars is about -80 degrees Fahrenheit.
Oh, wow.
But it's not just the average that's the problem. Near the equator, during the day, it can actually get up to a pretty comfortable 68 degrees Fahrenheit. But then at night, it drops to -148. So it's not just the cold.
Right.
It's the massive swings in
Yeah,
temperature.
that'd be impossible to deal with.
Yeah, super challenging.
So, okay, I think we've established that Mars is not exactly a welcoming environment,
Right.
but humans are, pretty resourceful.
Yeah.
I'm guessing there are, plans in place for tackling all these challenges.
Well, for sure. We're already working on some pretty innovative solutions. Let's start with the most basic needs: breathing and eating.
Yeah, those seem pretty important if you're planning on, living somewhere.
Absolutely. So, obviously, we can't breathe the Martian air. And bringing enough oxygen from Earth, well, that would just be incredibly difficult. So we need to figure out a way to make oxygen on Mars.
Right. Is there even oxygen on Mars?
So there might be some locked away in compounds in the soil, but there's a much easier source: water. Remember how we said liquid water evaporates instantly on Mars because of the low pressure?
Right.
Well, there's water ice at the poles and possibly even underground aquifers. We can take that water ice and, using electrolysis, split it into hydrogen and oxygen.
Okay.
In fact, we're already doing something similar on the International Space Station.
So we're taking lessons from space and applying them to Mars.
Exactly.
That makes sense. But what about food? You can't exactly pack enough food for a lifetime?
Nope, not at all. That's where things get really interesting.
Right.
Scientists are experimenting with hydroponics and aeroponics to grow food
Right.
on Mars. So in hydroponics, plants grow in a nutrient-rich water solution, no soil needed. And aeroponics, it takes it even further. You're suspending plant roots in the air and spraying them with a nutrient-rich mist.
Wow.
These techniques have already been successful here on Earth.
That's amazing.
Yeah, and they hold a lot of promise for feeding future Martians.
So you're telling me I could have a Martian salad?
Maybe one day.
Okay.
Yeah.
But there's another big challenge we haven't talked about: radiation. Mars has a much weaker magnetic field than Earth,
Right.
so we'd be exposed to all that harmful radiation from space.
You're right. Mars doesn't have that global magnetic field like Earth, which, acts as a shield, deflecting most of the harmful radiation from the sun and space.
Right.
Anyone living on Mars is going to be constantly bombarded with radiation.
That doesn't sound good.
No, it's not good. So habitats would need to be built with, radiation shielding in mind. Luckily, Martian soil, called regolith, is surprisingly good at blocking radiation. So habitats could be built underground or covered with thick layers of regolith. And here's a surprising solution: water. It's an excellent radiation shield.
So those Martian swimming pools we see in, sci-fi movies.
They could serve a double purpose.
Right. It's fascinating.
Exactly. Resourcefulness is key when it comes to surviving on Mars.
It makes you think differently about everything.
Totally.
All this high-tech equipment and these innovative solutions,
Yeah.
it's all going to need a reliable power source. Imagine something like solar power, like we use here on Earth, could be an option. Would it be effective on Mars?
So solar power is definitely an option,
Okay.
but there are some challenges. For one, Mars is farther from the sun than Earth, meaning less sunlight. And then there are those dust storms that Mars is known for. They can engulf the whole planet, blocking out the sun for weeks, even months.
Oh, wow.
Yeah.
So relying just on solar power.
That would be risky.
A little risky.
Uh-huh.
Are there any other energy sources that scientists are looking at?
There are. One promising option is nuclear power. NASA has been developing something called the Kilopower Project.
Okay.
It's essentially a small, portable nuclear reactor.
Wow.
It's designed to provide, a constant and reliable energy source no matter what's happening with sunlight or dust storms.
So nuclear power on Mars. That sounds like straight out of a sci-fi movie.
A little bit,
Is
yeah.
it safe, though?
So safety is the top priority, of course. And this kilopower reactor has been designed with multiple layers of safety features.
Okay.
It's incredibly robust, and it automatically shuts down if there's any malfunction.
That's good.
Yeah.
It seems like we've got a handle on, the basic survival needs.
Yeah.
But what about the habitats themselves? What would these Martian homes actually look like?
Well, there are a few ideas out there. One concept is inflatable habitats. They'd be lightweight, easy to transport, kind of like, giant space-age bouncy castles.
Oh, wow.
Once they're on Mars, they can be inflated and covered with a layer of that protective regolith. Another possibility is 3D printing. We could potentially use Martian regolith itself to 3D print habitats, creating sturdy and self-sufficient structures right there on Mars.
So 3D printing entire houses on Mars.
Yeah, pretty wild.
That is incredible. Which one do you think is more likely?
It's hard to say for sure. I mean, each approach has its own advantages and challenges.
Right.
Inflatable habitats, they're simple, cost-effective to transport and to set up. But 3D printing gives you more flexibility in design
Right.
and the potential for, more permanent, self-sufficient structures. Likely both approaches are going to play a role in, the future of Martian habitats.
It's exciting.
Yeah.
It really makes you wonder what life on Mars would actually be like.
Yeah.
I mean, we've talked about the technical challenges and the solutions.
Yeah.
But what about the human side of things? What about, the psychological impact of living on a completely different planet, millions of miles from home?
That's a really important thing to consider. Surviving on Mars isn't just about the physical challenges, it's about the mental and emotional toll as well.
Right.
We're talking about venturing farther than humanity has ever gone before, to a place where everything is different.
And it really makes you realize how adapted we are to Earth.
Right. We take for granted, the feeling of the sun on our skin, the wind in our hair, the sound of birds, just taking a deep breath of fresh air. On Mars, you don't have any of that.
That would be a hard adjustment.
Yeah, a huge adjustment. And I imagine the isolation.
Right.
That would be one of the biggest challenges.
Millions of miles from home with only a handful of, fellow astronauts for company.
Right, a small crew.
And communication with Earth wouldn't be instant either, right?
Nope. Because of the vast distances, there's a delay of about 20 minutes each way for radio signals.
So a simple phone call home
40 minutes.
would be a 40-minute ordeal.
Yeah.
Wow, that would be incredibly isolating.
It really would,
I've-
unlike anything we've ever experienced. And then on top of the isolation, there's that constant stress of living in such a hostile environment.
Right.
Every time you step outside your habitat, you're risking your life.
Yeah. It's hard to even wrap your head around that kind of pressure
It really is.
and the danger.
And then there's the confinement of living in a relatively small space
Right.
for months, maybe even years.
So it's not just the physical challenges, but the psychological ones, too.
Exactly. And space agencies, they're already working on strategies to deal with these psychological challenges. They're developing VR programs that simulate Earth environments.
Oh, that's interesting.
So astronauts have a way to, virtually escape the Martian landscape. And they're looking into the importance of crew dynamics, making sure that astronauts have the skills to maintain those relationships and support each other during long missions.
It sounds like we're just starting to understand what it would take to not just survive on Mars, but to actually thrive there.
Absolutely. It's a multifaceted challenge.
Yeah.
It requires pushing the boundaries of science, engineering, and even, our understanding of the human mind.
Well, we've covered a lot in this first part of our, Martian deep dive.
For sure.
From the basics of survival to the potential psychological challenges.
Yeah.
But this is just the beginning. Stay tuned for part 2, where we'll explore even more fascinating aspects of Mars exploration, from terraforming to the ethics of colonizing another planet.
Welcome back to our Martian adventure. Last time we talked about the basics of just surviving on Mars, dealing with that thin atmosphere, the crazy temperatures, figuring out how to breathe, eat, and, protect ourselves from all that radiation.
Yeah, it really was mind-blowing to see how much work and innovation goes into just, dealing with those challenges.
It really makes you appreciate how well suited we are to life here on Earth.
Yeah.
But today I kind of want to shift gears a little bit and talk about something even more ambitious. What if, instead of just surviving on Mars, we could actually transform it,
Oh, wow.
make it more Earth-like?
You're talking about terraforming, right? Like turning Mars from this cold, dry, practically airless world into a place where, you know, humans could potentially live without needing spacesuits?
Exactly.
That sounds like, straight out of science fiction.
It does, doesn't it? But scientists have been seriously thinking about this idea for decades.
Really?
Yeah. I mean, terraforming is a massive, massive undertaking.
Right.
The science is complex and the engineering challenges are immense. But the basic idea is to use technology to, like, manipulate the Martian environment, nudge it in a direction that's more suitable for human life.
So, okay, let's say, like, hypothetically, we wanted to terraform Mars. Where do we even start?
Well, one of the most important things would be to thicken the atmosphere.
Okay.
Mars' atmosphere, remember, it's super thin, and that contributes to those frigid temperatures we talked about. A thicker atmosphere would trap more heat, leading to a warmer planet, potentially even warm enough to melt those polar ice caps and create liquid water on the surface.
Right. That makes sense. But how do you thicken a whole planet's atmosphere? Where would all that extra air even come from?
That is the million-dollar question.
Yeah.
And there are a couple ideas out there. One possibility is to release the greenhouse gases that are already trapped on Mars.
Okay.
There might be tons of carbon dioxide frozen in those polar ice caps or locked away in the Martian soil. If we could release those gases, it could trigger a runaway greenhouse effect, warming the planet and thickening the atmosphere.
So it's kind of like, a planetary scale version of what's happening here on Earth with climate change, right? But wouldn't that, like, take centuries, if not millennia, to have any real effect?
It would definitely be a long process, absolutely. And that's why some scientists have, proposed more extreme ideas, like using giant orbital mirrors. They would reflect more sunlight onto Mars, to kind of speed up the warming process.
Wow.
Others have even suggested, seeding the planet with genetically engineered microorganisms.
Oh.
That could produce oxygen and other gases, slowly transforming the atmosphere.
So it's almost like we're gardening, but on a planetary scale.
In a way, yeah.
Okay, I can see why terraforming is such a huge challenge. We're not just, like, tweaking things here and there. We're trying to completely change the whole planet.
Exactly.
But okay, let's say we could actually do all this. We thicken the atmosphere, we warm up Mars. Wouldn't we still have to deal with that radiation problem? I mean, even with a thicker atmosphere, we'd still be exposed because Mars doesn't have that protective magnetic field, right?
You're absolutely right. That lack of a global magnetic field, it's a big obstacle for terraforming.
Yeah.
There have been some pretty out there ideas for creating an artificial magnetic field for Mars.
Okay.
One concept involves building this massive magnetic shield
Wow.
at a specific point between Mars and the sun. And that shield would deflect the solar wind, that stream of charged particles constantly flowing from the sun.
Right.
That's a major source of radiation.
So a magnetic shield for an entire planet. I can't even begin to imagine the engineering that would go into something like that. It seems almost impossible.
It does seem impossible.
But, landing on the moon once seemed impossible.
Yeah.
And look where we are now.
Exactly. What seems impossible today could be totally normal tomorrow.
Right.
But we got to remember that terraforming isn't just about, overcoming technical challenges. There are ethical and philosophical questions, too.
Right. Like, assuming we could actually terraform Mars, should we? What gives us the right to just completely change another planet?
That's a big question a lot of people are debating right now. As some people believe we have this moral obligation to spread life throughout the universe, and terraforming Mars would be a step in that direction. Others argue that we have no right to interfere with, the natural order of things, even on a seemingly lifeless planet like Mars.
That's a tough question, especially when you think about the possibility of, microbial life already existing on Mars, even if it's just simple organisms hidden somewhere beneath the surface.
Yeah, it's a good reminder that we need to be careful, proceed with caution and humility. We don't want to accidentally destroy a unique ecosystem just because we're trying to create a second Earth.
Right. We've got to be responsible about it.
Yeah.
But even if we, set those concerns aside for a minute, there are other questions. Like, if we did terraform Mars, who would get to live there?
That's a great question. And it's one that's, probably going to become more and more important as our technology keeps advancing. Would it be open to anyone who could afford the trip? Would there be some kind of selection process? favoring certain skills or professions? Would we create a whole new Martian society with its own laws and customs?
It's hard to even, like, imagine all the
It
possibilities.
is, yeah. It's really exciting.
It's like we're on the verge of this whole new era
Right.
of human exploration and
We
expansion.
are. It's an amazing time to be alive.
It is.
And who knows what we'll find on that red planet?
Well, we've definitely covered a lot of ground today, from, the actual mechanics of terraforming to the ethical and societal questions it brings up.
Yeah.
But there's one more big question that we need to tackle. The question that has, fascinated humanity for centuries: is there life on Mars? Or was there ever life on Mars?
The age-old question. Stay tuned for part 3, where we'll dive into the evidence, the missions, and the exciting possibility that we're not alone in the universe.
Welcome back to our deep dive into all things Mars. We've talked about, the challenges of surviving on this totally alien world, the amazing idea of terraforming it, and even, thought about the big questions about establishing a human presence on another planet.
Yeah, it's been a wild ride so far.
It has.
Right.
But now we're getting to, like, the biggest question of all. Is there life on Mars? Or was there ever life there?
It's the question, right? I mean, it's fascinated people for centuries, and for a long time it was just, pure speculation. But in the last few decades, we've actually moved beyond just guessing.
Yeah.
We're actively searching for evidence of life, past or present. And we're doing it not just with, powerful telescopes here on Earth, but with rovers that are actually on Mars.
It's amazing to think about, like, having robots on another planet
I know.
searching for signs of life. So what are we even looking for? Are we talking about, like, little green men hiding behind rocks?
I wish. No, it's probably going to be a lot more subtle, at least for now. The focus right now is on finding evidence of microbial life. So either life that's still hanging on somewhere on Mars, or signs of past life, like fossils or chemical signatures that tell us, hey, life was here.
So basically, like, microscopic Martians.
Exactly.
Have we found anything so far that, hints that life might have existed or even still exists on Mars?
There have been some really interesting findings. For example, the Curiosity rover, it's been exploring Gale Crater since 2012.
Right.
Well, it's found methane
Okay.
in the Martian atmosphere.
Methane.
Yeah, and methane, you see, can be produced by geological processes, but it can also be a sign of biological activity. So finding methane on Mars is kind of like seeing smoke.
Right.
It's like, maybe there's a fire, but it's not definite proof.
It definitely makes you curious, like, what's going on down there?
Uh,
Are there any other clues that suggest Mars could have been habitable in the past?
there's actually a lot of evidence that points to a past where Mars was warmer and wetter.
Really?
Yeah, pictures from orbiters, they show what look like dried up riverbeds, lake basins, and even like ancient coastlines. And rovers on the ground, they found minerals and rock formations that only form in the presence of liquid water.
So it's like we're putting together this Martian puzzle,
Yeah.
one clue at a time, and
Exactly.
it's showing us a picture of what Mars might have looked like billions of years ago.
It's amazing, isn't it?
It is. It makes you wonder, like, if Mars was habitable back then, did life actually start there? And if it did, what happened to it?
Those are some of the biggest questions that are driving Mars exploration today. And one of the coolest things about this search is that, we're not just looking at the surface anymore. A lot of scientists think that if there's life on Mars today, it's got to be underground, protected from all that radiation and the extreme temperatures.
So future missions might, be drilling down, looking for underground water or caves that could have life.
Exactly.
What kind of missions are, coming up that could help answer these questions?
Well, the Perseverance rover, it landed on Mars in 2021, and it's busy collecting rock and soil samples.
Okay.
And eventually those samples are coming back to Earth.
well, that's incredible.
I know, right? It'll be the first time we can actually study pieces of Mars in our labs.
It's like, what secrets are they hiding?
uh,
Are there other missions that are, specifically focused on looking for life?
There are. One that's particularly interesting is the Martian Moon's Exploration Mission, MMX, they call it.
Okay, MMX.
It's going to launch in late 2020s, and it's going to explore Phobos.
Phobos, that's one of Mars's moons, right?
Right, one of its 2 small moons. Scientists think Phobos might actually be a captured asteroid.
The captured asteroid.
Yeah, and it could have pieces of Mars that were blasted off, billions of years ago.
Oh, from impacts.
From impacts, exactly. So by looking at Phobos, we might actually be learning about the history of Mars itself.
Oh, that's so cool.
Right.
That's like a time capsule.
Exactly.
But let's go back to, the possibility of life on Mars today. If there are, microbes hiding underground, how would we even find them?
Well, future missions might have like special drills
Right.
and instruments that can actually analyze the chemical composition of, underground water or rock samples.
Okay.
We might even send probes into Martian caves to look for like whole microbial communities.
It really feels like the search for life on Mars is, just getting started. But I can't help but wonder, what if we do find evidence of life? What
Yeah.
would that mean for us, for how we see ourselves in the universe?
It would be huge, a truly profound discovery. It would mean that, life isn't unique to Earth. It might be common throughout the universe. And
Wow.
it would open up so many more questions. How similar is this Martian life to Earth life? Did life start on Mars and then come to Earth? Or the other way around? Or did it, arise completely independently on both planets?
It's just amazing to think about. And it really makes you realize that going to Mars isn't just about, you know, exploring another planet. It's about pushing the boundaries of what we know, asking these huge questions about life itself, and, in a way, searching for ourselves in this vast universe.
It's a journey of self-discovery for sure.
It
A
is.
quest to figure out where we fit in the grand scheme of things.
Well, listener, that brings us to the end of our Martian deep dive. We've explored the challenges of surviving there, the incredible idea of terraforming, the ethical side of colonizing another world, and of course, that exciting search for life. As we keep exploring Mars, who knows what we'll discover? Keep looking up, keep asking questions, and keep exploring. This is just the beginning of humanity's amazing journey into the cosmos.